Hey everyone, Math 103, we're working on section 5.6 today, solving equations by factoring. Please start with a warm-up. So first one, we have an a equals 1 trinomial. We want two numbers to multiply to get negative 16, add to get negative 6. That's going to be 8, or negative 8 and 2. X minus 8, x plus 2. Second one, we got a 8 does not equal 1 trinomial, so we need to use the AC method. So AC is 2 times negative 21, which is negative 42. All right, now we need two numbers to multiply to get negative 42 and add to get negative 11. All right, so there's our numbers, negative 14 and 3. So we're going to break up that middle term into negative 14x plus 3x. And now we'll factor by grouping. Factor out a 2x from the first pair. X minus 7. Factor out a 3 from the second pair. X minus 7. So we get x minus 7 times 2x plus 3. So as you can probably tell from the section title, factoring is going to be a really important skill for what we're doing in this section. So what we're going to be doing is we're going to be using this principle of zero products. So I've got a challenge here. Any student can find two non-zero real numbers that multiply together to get 0. You earn an automatic A for Math 103. Well, as you may have guessed, it is not possible, and we'll see why. So, let's say we have two numbers that multiply to equal 0. One of them has to be 0. That's the only way it can happen, because anything you multiply by 0 is 0. So 3 times 0 is 0, 0 times 5 is 0, and it even works with binomials. I can take 0 and multiply it by this binomial x plus 3, and that's going to be 0. Because basically what we're doing here is distributing 0 into the binomial. So 0 times x and 0 times 3. Same thing over here. 0 times this binomial is 0. But what if we have two binomials multiplied together that equal 0? Well, that's where we can use the principle of zero products. We know from this property here, that if we have two things multiplied together that equal 0, one of them has to be 0. At least one. They both could be 0. So we're going to use that fact to solve equations that look like this. We're going to break this up into two separate equations and then set each of those equations equal to 0. That way, when we solve them, we get the value such that when we plug it back up in here, we're going to get a 0 for one of these binomials. And as we've seen up here, if you multiply a 0 by any binomial, you get 0. So that will solve the equation if we can make one of these binomials 0. So the two numbers that will accomplish that are negative 3 and 2. So those are the solutions to that equation. All right, try this out with your turn number 1. So we're going to do this. We're going to take these two binomials, split them up into two separate equations, and solve them individually. So we got x minus 5 equals 0, and x plus 8 equals 0. So the two solutions then would be 5 and negative 8. All right, part B. Now with this one, we're going to need to factor first. we need to get it into a form that looks like this. So we need two numbers that multiply together to get negative 21 and add to get negative 4. So that's negative 7 and 3. All right, now we will use the principle of zero products. Split this thing up into two separate equations. X minus 7 equals 0 and x plus 3 equals 0. Solving these, we get x equals 7 and x equals negative 3. So the quadratic equation in standard form, we get ax squared plus bx plus c equals 0. So if we have some sort of an equation and it's not in standard form like this, we're going to need to put it in standard form and then go through this procedure, factor, and then split it up. So we got an example here, x squared equals x plus 30. So we want to get this thing in standard form where all the terms on one side of the equation and it's set equal to 0. So what we can do here is subtract x from both sides of the equation and subtract 30 from both sides of the equation. So what do we get? We get x squared minus x minus 30, and these all cancel, so we get 0 on the right-hand side. And now we have an equation in standard form. Now there's a shortcut you can use when working with equations like this. Notice what happened to these terms as I took them from the right-hand side and moved them to the left. The x turned into negative x, and the 30 turned into negative 30. So if you ever want to take a term and move it across the equal sign to the other side of the equation, just change the sign of the term. All right, now we're going to factor this. So we need two numbers to multiply to get negative 30 and add to get negative 1. So that's going to be negative 6 and 5. So this factors into x minus 6 times x plus 5 equals 0. And now we use the principle of zero products. Split this thing up. X minus 6 equals 0 and x plus 5 equals 0. So x equals 6 and x equals negative 5. Your turn, number 2. First thing we need to do with this one is to get everything to one side of the equal sign. It's best to keep the x squared term positive, so let's move everything to the left. So we'll subtract 30 and add 7x. In other words, we're going to change the sign as they go across the equal sign. So the negative 7x turns into positive 7x, and the 30 turns into negative 30. And now it equals 0. So now we've got it in standard form. Now we can factor this thing. So we need two numbers that multiply to get negative 30 and add to get 7. And that's going to be 10 and negative 3. So this factors into 10 plus or x plus 10 times x minus 3. So splitting them up and solving individually, we get x equals negative 10 and x equals 3. So some of these are going to require some work to get them in standard form. Here we've got one that needs to be simplified first, so we're going to distribute to remove the parentheses. So it gives us x squared minus 11x on the left-hand side. And now we'll move the 12 over to the left-hand side. So we got x squared minus 11x minus 12 equals 0. Factoring this, we need two numbers to multiply to get negative 12 and add to get negative 11. That'll be negative 12 and 1. So that factors into x minus 12 times x plus 1 equals 0. And now we can split them up. So they're both equal to 0. And x equals 12. And x equals negative 1. Your turn, number 3. So we're going to need to get this thing into standard form. So first thing we need to do is simplify on the left-hand side by foiling. So first gives us x squared, last plus 4x, outside gives us plus 4x, inside minus 8x, and last minus 32. Now we'll combine the two x terms. X squared minus 4x minus 32 equals negative 35. All right, now I need to get 0 on the right-hand side, so I'm going to add 35 to both sides to get rid of that. So we get x squared minus 4x plus 3 equals 0. Now we need two numbers that multiply to get positive 3, add to get negative 4, that's negative 3 and negative 1. So that factors into x minus 3 times x minus 1 equals 0. Now we'll use the principle of zero products. Split this thing up. Set them both equal to 0. And solving, we get x equals 3 and x equals 1. All right, so the procedure then for solving a quadratic equation using the principle of zero products. We're going to write the equation in standard form. So that's moving from this into this form. So here's standard form. All right, now we're going to factor completely. Here's standard form. One more step. Okay, now we'll factor completely to get into this form. Then use the principle of zero products to break it into two separate equations and solve each individually. All right, make sure you check these with the original equation. Don't worry about writing in the set notation. Now you can write it just like this. All right, now we're going to look at a few special cases. We have 3x squared minus 9x equals 30. So putting this thing into standard form, I'm going to move the 30 to the left-hand side. That's going to make it negative. So we get 3x squared minus 9x minus 30 equals 0. So now we're in standard form. Before we do anything here, before we start factoring, remember the first step in factoring is to always look for a GCF. So all three of these numbers are divisible by 3, so we're going to divide out the 3 first. And now we've got a much easier thing to factor inside the parentheses. And the nice thing about when we can factor out a whole number like this, or any kind of real number, is look what happens when we divide it out. We're going to divide both sides of the equation by 3. This turns into 1. So we get x squared minus 3x minus 10 equals, and 0 divided by 3 is 0. So anytime you can factor out a number, it just disappears. Now we can factor this thing. You need two numbers to multiply, you get negative 10. Add, you get negative 3, so that is positive 5, or negative 5 and positive 2. Now we'll split this thing up. And we get 5 and negative 2. And that brings us to your turn number 4. So we'll get into the standard form first by moving the 12 to the left-hand side. That's going to make it negative. Now notice each of these coefficients can be is divisible by 4. So we'll factor out 4. We go x squared plus 2x minus 3 equals 0. Now we've got a much easier thing to factor here inside the parentheses. So I'm going to get rid of the 4. So we got x squared plus 2x minus 3 equals 0. Now we'll factor this. So we need two numbers to multiply to get negative 3. Add and get 2. So that'll be x plus 3, x minus 1. And now we can split this up. X plus 3 equals 0. X minus 1 equals 0. And we get x equals negative 3. And x equals 1. All right, next up, we got x squared plus 64 equals 16x. So I'm going to take this 16x term, move it over to the left, make it negative. And now we have a perfect square trinomial. That factors into x minus 8 squared equals 0. Now, since we have x minus 8 times x minus 8, we could split this up into two separate equations, but they'd be the same. X minus 8 equals 0. So we only need to solve one of these. So x equals 8. So this is one of those rare times when we get a single value, a single solution for a quadratic. And that happens when we get a perfect square trinomial like this. And we get the same equation. We get one solution. It's called a double solution. Your turn, number 5. squared plus 100 equals negative 20x. So to get in the standard form, I'm going to take this term, move it to the left. Now we can factor this. We got another perfect square trinomial. So we get x plus 10 squared equals 0. So set that binomial equal to 0. There's two of them, they match. We only have to do one. And we get x equals negative 10. And here's an example showing how important the factoring techniques we've learned so far are, because they're just going to keep coming up. So here we have difference of squares, perfect square, perfect square, perfect square. So to find A, we'll take the square root of the first term and get 2x. And to find B, square root of the second term, and get 7. So that's going to give us 2x plus 7 times 2x minus 7 equals 0. Now we can set each of these individually equal to 0. And solving those, we get 7 halves and negative 7 halves. Your turn, number 6. Got another difference of squares here. Take the square root of those, we get x for A and 10 for B. So factoring, we got x plus 10 times x minus 10. Set these equal to 0 individually. We get 10 and negative 10 for the answers to that. Now the principle of zero products doesn't just work with two terms, it can work with any number of terms. So for an expression like this, when we start factoring this, of course we're going to start with a GCF, as we always do. Greatest common factor of 3x to the third and 27x is 3x. So we'll factor that out and get x squared minus 9. Now we have difference of squares here, so we can factor this into x plus 3, x minus 3. So now we have 3 different factors, and we're going to set all 3 of them equal to 0. In solving all 3 of them, we get x equals 0, x equals negative 3, and x equals positive 3. So we should have 3 solutions because we've got a degree 3 polynomial. Your turn, number 7. So we've got a GCF we can factor out here. It is 2x. So we get 2x times x minus 25. X squared minus 25. Now we've got difference of squares here. And that factors into x plus 5, x minus 5. Now you've got 3 factors. We'll set all 3 equal to 0. Solving, we get x equals 0, x equals negative 5, and x equals 5. Up next, we've got some applications involving these techniques. So take the given information, plug it in to the appropriate variable, and then solve using everything we've learned today. So first application, throwing stones. We're given an equation. D equals Vt plus 16t squared, where d is the distance, v is the initial velocity of the stone, and t is the time. We are given initial speed of 12 feet per second, so that's going to go in for v. And the distance says the well is 130 feet deep, so the distance is 130. And there's our equation. 130 equals 12t plus 16t squared. So I'm going to put this thing in standard form by moving 130 to the right. And I'm going to put it in descending order. And we get 16t squared plus 12t minus 130 equals 0. So before we start factoring this, we need to factor out a GCF. 2 divides evenly into all 3 terms, so we'll divide that out. And that gives us 8t squared plus 6t minus 65 inside the parentheses. Now we can divide both sides by 2 to get rid of the 2. And 0 just equals what's inside the parentheses. Now we can factor this thing. So we're going to have to use the AC method. It's got 8 times negative 65. So it gives me an AC of negative 520. Now we need 2 numbers to multiply to get negative 520 and add together to equal 6. So those numbers are going to have to be pretty close to each other since they're only separated by 6. So I'm going to pick 26 and negative 20. Multiply 26 times negative 20, we get negative 520, and they're separated by 6. So there's our 2 numbers. All right, I'm going to replace 6t with these 2, so plus 26t, oops, 26t, minus 20t, minus 65. And now we can factor by grouping. So out of 8 and 26, we can factor out 2t. That gives us 4t plus 13. And over here, we can factor out negative 5 and get 4t plus 13. And the factorization then is 4t plus 13 times 2t minus 5. Now we use the principle of zero products and split this up. 4t plus 13 equals 0. 2t minus 5 equals 0. Now when we solve this one, we get negative 13 fourths. Over here, we solve this one, we get 5 halves. Time cannot be negative in this case, because that would mean we're going backwards in time. So that doesn't make any sense. So the negative one we could ignore. The answer then will be 5 halves. So make sure to include units and a little description of what it is. It will take 5 half seconds to reach the bottom of the well. All right, number 2, we got a landscape architect. Design a grassy area with a flower bed border. And there's a diagram there it shows you. Now, grassy area is to be 12 meters by 16 meters, but they haven't decided yet on the size of the flower bed. So we're going to leave that as a variable, x. How wide should that border be if the total area together should be 285 square feet? And what's given is the area equation. Area equals length times width. First question asked, write an expression for the length of the entire area, including the border. So we've got 16 here, we got 12 here, x here, and x here. So what they're asking for is the length of the entire area from here to here. So we've got 16 to here, and we have x to here. What do we do to those two values? Well, we want the total length. Total means addition. So we're going to add them together. So the length is x plus 16. And the width works the same way. We've got 12 here and x here, add them together. We get x plus 12. And now we can use the area formula. The next question says, write an equation using your expressions. Okay, so area equals the length times width. So we're going to plug in everything we know. The area is 285 square feet. So 285 goes here. The length, we have an expression here, x plus 16, and the width, x plus 12. So let's FOIL this out. X squared plus 12x plus 16x plus 192. Combine like terms. X squared plus 28x plus 192. And let's see, does not ask for a standard form or anything, so this would be fine to put in there. If you put that in there, doesn't say to simplify, so any one of these versions would be fine to put in for that. All right, now we're going to solve this equation to find the width of the border. So we need to get this thing into standard form. All right, now I'm going to subtract 285 from both sides. So we got 0 on the left. And 93. Okay, x squared plus 28x minus 93. So now we need to factor this thing. So we need two numbers that multiply to get negative 93 and add to get 28. So the factors of negative 93, we got, 93 and negative 1. We got 31 and negative 3. Well, if I add those two together, it's 28. So there we go. X plus 31, x minus 3. Now we use the principle of zero products, break this up into two separate equations. X plus 31 equals 0, x minus 3 equals 0. Solving them individually, we got x equals negative 31 and x equals 3. So can we have a border that's negative 31 meters wide? No, of course not. So we'll ignore that one, and x equals 3 is our solution. So the flower bed is 3 meters wide. All right, that's it for this section. If you're struggling at all with these, it's probably because you're not quite adept enough at factoring yet. It's very common at this level it takes a few tries and some additional problem set sessions to really get factoring down. So I recommend just keep working at factoring and it will pay off. Have a good day, everyone.